Hello everyone, welcome to this course on machine learning using Python programming. In today's class, we will see one of the very important technique of classification, that is logistic regression. So, we will see, we have already seen linear regression or simple linear regression, and now we are going to see logistic regression. So, let us see first of all difference between linear regression and logistic regression. So, this is the case of linear regression, where we have two features, two predictors, experience and salary, and this is the response variable values, and we are seeing there is a linear trend, and when we will learn the model, suppose we will get this red line as the model learned. So, in this case we know how we learned the model. There was this y minus y cap, where this is the actual value and this is the predicted value, and we minimize sum of a square of this error, or this is called as SS residual. So, we try to minimize this, and this is our loss function, and we minimize it over all the instances, and then we get this line as the learned model. So, here we know in case of linear regression or in case of simple linear regression, multiple linear regression, polynomial regression, in all these cases we have seen the response variable was continuous variable, while in case of classification we know that it is a categorical variable. So, in case of classification we can't use this regression models, we need some other models, because here your response variable will be some categories or some labels. Like if we see this example, suppose we can here we are having this variable age, and based on that age we are deciding whether the person will take that action, any particular action, or will not take the action. So, this is a problem of classification, and here your predictor is age and your response variable is action, and there are only two values in this action, y or n, yes or no. So, when we will plot this data set, so for few persons, when for them action is 0, so those will be plotted here, and for other persons who took the action, those will be plotted here. So, if we will suppose learn a simple linear regression from this data set, in that case what we will get? We will get this type of line or model that will be learned. So, we can say that now how good this model is, because our points are here and here, while this predicted response variable values are on this line. So, of course, it is not the perfect model, or it is, we can say that your model will not give you the correct values, because it is this is giving you values that are numerical values, and you want only two values, 0 and 1. So, we will see how we can convert the values that are given by logistic linear regression into 0 and 1. If we find this technique, then we can predict first, we can learn first simple linear regression, and after that whatever output is output of that we are getting, that we will convert to 0 or 1. So, here we can say that these values that are between age 35 to 55, these values are between 0 and 1. So, we can say, we can set one threshold here. So, if these values are less than 0.5, the predicted values that are less than 0.5, we will map them to 0, and all the values that are greater than 0.5, we can map them to 1. So, in this way we can say that, because here the trend is that if age is less, then that performing action possibility is less, and when age is greater, so for persons whose age is greater, there are chances that the person will perform that action. So, here we can say that for all those persons where age is greater, or the model that we have learned, the simple linear regression model that we have learned, if its value is greater than 0.5, if its value is greater than 0.5, then we will map these values to 1. So, for all the persons of age 35 to 55, it is correct, but if we talk about persons whose with age greater than 55 or persons with age less than 35. So, here we are getting values that are greater than 1. So, we can say that we can map all the values that are greater than 1 to 1, and we can map all the values that are less than 0 to 0. So, in this way we can say that we can predict, we can simply learn simple linear regression, and then output of that we can map to 0 and 1. So, this is one way, of course, not the perfect way, this is not the logistic regression we will see, but the idea is similar to this, where we will convert numerical values we will convert to values that are between 0 and 1, and then we will treat these values as probabilities. So, we will say that our model will finally give the probability of belonging to a particular class. So, here we can say that probability of belonging to the class action 1 or class action y, and then if that probability is suppose 0.9. So, we can find out what is the probability of class probability of that new instance belonging to class number 0. So, that probability will definitely be 1 minus 0.9. So, it means 0.1. So, this is the idea, let us see it in detail, and this concept I have taken from a course from machine learning A to Z from Udemy. So, this example I have taken from there. So, you see here all the values that are greater than 1 are mapped to 1, and all the values that are less than 1 are mapped to 0, and then all the values that are between 0 and 1, those we can treat as a probability of belonging to one class. So, here we can say that probability of, because these values are very less. So, probability of belonging to class 1 is very less. Here these values are very large, it is almost close to 1. So, for age, for persons where age is greater than or equal to or around 55, then the class the probability of belonging to class 1 is high. So, let us see how we can do this. For that there is a sigmoid function. So, for there is a sigmoid function, and this sigmoid function range is always from 0 to 1, and this is the function. So, g z is equal to 1 upon 1 plus e to the power minus z. So, what will happen here? We will provide, suppose if we see it here, if we see, so these are the different values, these are different values that will be predict that what we want if we provide some value for any instance z, and that value should map to the probability of belonging to some particular class. So, what is the idea here? Idea is that we will if we say that these are the points belonging to one class and these are the points belonging to another class, and then this is a simple linear regression. So, what we say, if suppose this is the point x and this is the distance of that point x with the boundary line. So, what we can say that if this distance is high, then we are more confident that this point is belonging to class number 1, and suppose this is class number 2. If this point is close to the boundary line, then again since it is on the right hand side, so we will say that it is belonging to class 1, but you can say that your confidence is less because this distance is less. So, what we can do, we can calculate distance of each point with this boundary line, and that based on that distance, if that distance is positive, we will say that it is belonging to class 1. If this distance is negative, we will say that it is belonging to class 2. And so, this distance, what is this distance? We know that this distance is W transpose x upon mod of W. So, this where your boundary this classification boundary equation is W transpose x is equal to 0. So, this is the distance. If we put this distance W transpose x here, so this distance will be, all these distances will be converted to 0 to 1. So, what will happen? We can say that now we will see the graph of this sigmoid function. So, the graph of the sigmoid function is like this. When we will provide values that are greater than 0, so suppose 0, 2, 4 and 6, and here these values are 2, minus 4, minus, so this is basically suppose minus 6 and so on. So, here so how this function when we will plot, how this will work, it is basically this function, if it is suppose 0.5, this value is 0.5. So, this function value will be like this here and it will be like this here. So, we can say that when we are providing the value of z that is positive, then its value will be greater than 0.5, and when we will increase this value of z, its value, the function value z will become high and finally it will be close to 1. In the same way, when you will provide some negative value as a z, then its gz function value or sigmoid function value will be less than 0.5, and finally when the value of z is very high in negative, in that case this sigmoid function value will be close to 0. So, here what we can say that we are getting values only between 0 and 1, and that is why we can treat it as a probability. So, when the distance is less, in that case when we will provide as a z here this distance. So, if that distance is very less with the boundary, in that case your probability is close to 0.5, and we are not that much confident that whether it is belonging to class C1 or class C2, because it is close to the boundary line, and here you can see that at that time probability is also close to the 0.5. So, we are not so this when we are using this distance as a z here. So, your sigmoid function is giving you correct probabilities of belonging to a particular class, but of course, this since here we are saying that your probabilities are between 0 and 1. So, we can say that this is a probability of belonging to class 1, and 1 minus of that will be probability of belonging to class another class. So, this can be applied only to the binary classification case. So, let us see now. So, now we can say that in case of linear regression, what was the function? Your function was r d to the r, where r d is your data is d dimensional data set, and features are some real numbers, and you are mapping it to a single dimension value. So, that is you can say that your predicted value, predicted class or basically predicted value will belong to this is the case of regression. So, this is a predicted value of the response variable. This is a predicted value of the response variable. So, predicted value of the response variable we have already seen, it is W transpose x, and where x is belonging to this d dimensional data set, and y is the actual class. So, this was a case of linear regression, while here what we have done. So, in case of logistic regression, this W transpose x, that was the predicted variable value in case of logistic regression, or we have seen that this is the distance of point x with the boundary. So, when we will provide this value in the sigmoid function, it will give you probability of class y given x and w. So, definitely we will learn from the data value of this w, best values of w, and for that w, when we will use those w, then we will get the probability of belonging to class y for the given instance x. So, here we can say that this is the sigmoid function. So, in the sigmoid function you see this is the sigmoid function, and where z in case of z. So, z we provided minus W transpose x. So, in this way your distance is now converted into 0 into values between 0 and 1, and this we are treating as the probability of belonging to a particular class. So, this is the same thing is written here. You see, if W transpose x is 0, in that case this sigmoid function value will when we will provide this W transpose x means 0 in the sigmoid function, its value will be half. So, we can say that W transpose x is 0. So, it means x is the new point when we are putting it on the boundary equation. So, it is showing that new instance is on the classification boundary, and that is why here you can see that when you are putting that distance of point with the boundary in the sigmoid function, you are getting value half. So, half means probability of belonging to class 1 is half. So, it means probability of belonging to class 0 is also half. So, both are giving you the same idea. When W transpose x is greater than 0, it means point is on one side of the classification boundary. In that case, you see this sigmoid function value is also greater than half. So, your probability of belonging to class 1 is greater than half, and when W transpose x is less than 0. So, when your point x is on left hand side of the boundary, in that case your probability is less than half, sigmoid function value is less than half, means probability of belonging to class 1 is less than half. So, here now what we will do, we will initially take any random values of W, and then using this sigmoid function we will try to predict probability of belonging to class 1 or class 0. Then definitely your probabilities, or you can say that your prediction may be wrong prediction, because you have taken random values of your parameters w, because we do not know what is the actual boundary, we do not know. So, we do not know the equation of the boundary, we know equation of the boundary is w transpose x is equal to 0. So, we do not know what are the correct value of w. If we know that, in that case we know what is the actual boundary, but since we do not know what is the actual boundary, so we have taken random values. Initially we have taken random values of w. So, we started from any one of these equation of line, and then we will try to find out the best value of w. So, for that we need some loss function or your objective function, and then there are the two cases. You can take your loss function as a sum of squares for case of regression, and generally for case of classification we take cross entropy function. So, why we do not take this sum of a square, this square function, why we do not take, as we take it as a logistic linear regression case. If we will take it as a loss function, in that case generally what happens, since here this is the sigmoid function, this is your hypothesis, this is your prediction, and prediction we are doing using the sigmoid function. So, in that case when we will, so this is this sigmoid function we have seen, it is not linear, this is not linear function, while in case of simple linear regression when we were using this as a cost function, here this function was our hypothesis was linear. So, this function was linear. So, when this is not linear, in that case this cost function will have more than one local minima, and in that case it will be difficult to solve this problem, minimization of this cost function, it will be difficult. So, we should now see some other function that is more suitable. So, generally for in case of classification we take cross entropy as a loss function. So, what is this cross entropy function? This cross entropy function is basically measure of difference between predicted probabilities of a model and the actual probabilities of the target variable. So, we have seen this is a case of binary classification, because your sigmoid function is giving you probabilities between 0 and 1. So, if it is giving you probability of 9, so we will say that for instance, for test instance x, if this is the predicted probability, then 0.9 is the probability of belonging to class C1. If it is for any instance x2, it is predicting 0.2, it means there is a 0.2 probability of belonging to class C1, and so on. So, now we will find out what is the actual class. Suppose the actual class for this instance is C2, and in the same way we can find out this also. So, in this case, since it is greater than 0.5, so definitely we will your model will finally assign class C1 to x1 instance. Here this probability is less than 0.5, that is why your this logistic regression will assign class C2 to new instance x2. So, this will be assigned, but suppose their classes are different, actual classes are different. Its class is C2 while predicted class is C1, and its class actual class is C1 while the predicted class is C2. So, your cross entropy loss function is a measure of difference between these predicted probabilities and the actual probability. So, actual probability of belonging to class C1 in this case is 0, but it is giving you probability 0.9 of belonging to class C1. Here you can see that it probability of belonging to class C1, this actual probability is 1, while it is saying only 0.2 probability is belonging to class C1. So, these are the differences. So, a cross entropy function is defined on these two probabilities, and based on that, so it is defined like this: cross entropy loss function is summation over y log p plus 1 minus y log 1 minus p, where y is the true class level and p is the predicted probability of the positive class. So, this is a binary classification. So, definitely we are saying that the probability that is predicted by the logistic function is corresponding to suppose positive class. So, this p is the predicted probability of the positive class and y is the true class. So, definitely your true class may be 0 or 1, yeah, we can say that it is negative or positive. And then 1 minus y log 1 minus p. So, there are two terms and there is a summation over all the instances. So, for all instances what is the actual class and what is the probability of predicting the positive class for that instance. We will take summation over all the instances and then we will get this cross entropy loss function. Now, our objective is to reduce this loss function. So, initially whatever probabilities your binary logistic function is giving, we will and then based on that we will find out this loss function value, and if loss function value is greater than the threshold, in that case we will update our parameters. So, we know we can use any method, any optimization method for finding the optimal values of parameters. So, gradient descent suppose. So, using gradient descent we can update. So, here what are our parameters? W, because we have seen we are providing Wx in the sigmoid function. So, W is the parameter. Initially we have taken some. So, here theta j we can write it as Wj is equal to Wj minus alpha delta j upon delta Wj and so on. So, we can optimize it and we will get the best values of W, and in this way your logistic regression learns from the data. And now we will see in case of multi-class classification how we can do it. Till now we have seen we used sigmoid function, and using sigmoid function of course your probabilities are between 0 and 1, and that is why you applied it for the binary classification problem. But if the problem is multi-class classification, in that case there are two possibilities. The first possibility is that suppose this is a 3-class classification problem, then we will learn 3 models. First model will be learned group class 1 versus the rest of the 2 classes. Then second model will be learned class 2 versus rest of the 2 classes, and class 3 versus rest of the 2 classes. So, here this, because we are using suppose sigmoid function, we are using logistic regression. So, that is only for the binary classification case. So, this 3-class classification problem is converted into 3 binary classification problems, and now we will find out, we will run these 3 models, and then we will find out for the new instance. Using the first model, we will find out what is the probability of belonging to class 1, what is the from the second model we will be getting the probability of belonging to class 2, and from the third logistic regression we will find out the probability of belonging to class 3, and whichever is the high we can assign that class. So, using sigmoid function, using logistic regression, we can solve multi-class classification using binary classification like this. Otherwise, we use generally softmax classifier. So, this softmax classifier, in that case what happens? So, in case of multi-class classification, we can say that for each class we must have some score. So, if there are classes C1, C2 up to Cn. So, if we can find out some score for C1 class, some score for C2 class, some score for Cn class, and then for the score for which class will be maximum, that class we will give as an output of the instance. So, the same is written here. So, S of yi where yi is a ith class. So, we will calculate a score for each of the class, and definitely that score in that for calculating this score we will need to provide the test instance and your model parameters. So, after finding a score of all the classes, what we are doing, we are getting probability of class y given x and w. So, if they are C1 classes, so Cn classes, so we will find out probability of C1 given x I w, probability of C2 given x I w, and so on, and whichever probability will be highest, that class we will assign. So, here how we are finding this probability? So, score of the ith class upon sum of score of all the classes. So, in this way we will get the probability of belonging to a particular class, and here we can this is the example where this score is calculated. So, let us see this. So, suppose this is a 3 class classification problem. So, here we will calculate this value of z, means the score, and then that score we will in the, you see this in this softmax classifier, that score is put is set on the e to the power. So, e to the power that score upon summation e to the power all the scores. So, the same is done here. So, suppose this is score is calculated, and then we have calculated e to the power that score for all the classes, and then we have taken sum of this. So, then e to the power score of class 1 upon that sum, e to the power square of class 2 upon the total sum, and so on. So, this is giving you the probabilities of belonging to different classes. So, whichever is the highest, that we will assign to that class. Now, we are getting probabilities, but the same thing is we have started from the random parameter values. So, we will need to find the optimal parameter values. So, we must have some loss function, and we have already seen we use cross entropy loss function. So, this is a cross entropy loss function. In case of binary classification, there were only 2 terms, and these were the 2 terms because those terms were corresponding to class 0 and class 1. Now, here we will have many terms, and these terms will be corresponding to each class. So, you see this is the actual class, and this is the probability of belonging to class to a particular class. So, if when j is equal to 1, we will say that probability of belonging to 1th class. So, that we calculated it. Here we have calculated the probability of belonging to class 1, probability of belonging to class 2, probability of belonging to class 3. So, all these probabilities we are getting from softmax classifier or softmax function. Then we will put these probabilities here for each and every instance. We will get what is the probability of belonging to class 1, what is the probability of belonging to class 2, and so on. So, and what is the actual probability of that instance actual class probability. So, using this cross entropy function, we will calculate this loss function, and then again we can use any optimization technique, generally gradient descent optimization technique, to find the optimal values of parameters. So, this is called as multinomial logistic regression or softmax regression. So, in this today's class we have seen logistic regression, and then in case of logistic regression we have seen sigmoid function. Using sigmoid function we converted the distance of points with the boundary to the probabilities. So, but this using sigmoid function we can solve only binary classification problem. If we want to solve multi-class classification problem, then we have seen here we have used this softmax function or softmax classification, and then in both of these two cases or in general for classification problems we use cross entropy function for as a loss function. So, in this way your logistic regression works. In case of binary classification we use sigmoid function, in case of multi-class classification we use softmax function. So, I hope this the idea of logistic regression is clear to all of you. So, I am stopping here. Thank you.